Welcome to Sanjay Godawat IIT and Medical Academy. My name is Uday Shankar. Now I am going to teach the kinematics. See, in this kinematics, we have to discuss the motion on a straight line. First, motion is a relative term. Body is rest. Body is rest means, suppose a point with respect to this one, a point at t equal to 0, it is at the same point. T equal to 1 second also here. T equal to 2 seconds also it is here. Then we can say that t equal to 100 seconds also it is here. Then with respect to this point, we can say that this point is at rest. Suppose at t equal to 0, this point is here. At t is equal to 1 second, this point is here. At t equal to 2 seconds, this point is here. At t equal to 100 seconds, this point is here. Then we can say that the body is in motion with respect to this. Okay? Rest and motion are relative terms. Relative means, suppose a person in a bus. Another person is here. For him, this person is moving along with bus. So, with respect to him, this person is in motion. But with respect to another person in the bus, this person is at rest. So, motion and rest depend on the frame of reference. They are relative terms. With respect to this person, he is at rest. With respect to this person, he is in motion. So, in this frame of reference, it is in motion. In this frame of reference, he is at rest. So, in this way, we can say rest and motion are relative terms. Now, we have to take that distance. Distance means the length of the path covered by a moving body in between 2 points. In between 2 points, irrespective of direction in which body is moving, is called a distance. For example, this is one point, this is another point. Now, one particle is moving in this direction. Another particle is moving in this direction. Another particle is moving in this direction. The length of this path covered by this moving body, in between the 2 points, irrespective of direction. For this one, this is the distance. For this path, this is the distance. For this path, this is the distance. The length of the path, we have to take this length by a moving body in between 2 points, irrespective of direction in which body is moving. We are not considering the direction. It is going in this way means this is the distance. It is going in this way means this is the distance. It is a scalar. It is a scalar. Displacement. The shortest distance between the 2 points. the shortest distance between these 2 points, between A and B, the shortest distance is, this is the shortest distance. It has particular direction. Suppose body is going in this way, but displacement is this one. This is the distance moved, but this is the displacement. It is the shortest. Suppose another body is moving in this way, but it is displaced from this point to this point, displaced from this point to this point. This is the displacement. It has particular direction. So, it is a vector quantity. Displacement is a vector quantity. Both for distance and displacement, SI units are meters, CGS units are centimeters. Distance between a given set of initial and final positions can have infinite values, but displacement is unique. Suppose if you take this point and this point, you have infinite ways you can go. Distance between a given set of points, initial position, final position, we can follow infinite ways. We have infinite values. But displacement is always unique. Only one value. It has only one value, displacement. Displacement less than or equal to distance. Distance is always more, but in a straight line motion, displacement and distance are same in a particular straight line. Distance and displacement both are same. But in another way, we can have infinite number of distances, but displacement is unique. Unique means it has only one value. Now, suppose a car starts from point P and follows the path as shown in the figure. First it starts here and it is going now in this way, and it is coming in this way, it is going in this way. Finally, car stops at R. Find the distance travelled and the displacement of the car. Radius. This radius is given 11 by pi meters. This radius is 4r. This radius is r. Now distance. Distance means we have to count the length of the path. The length of the path. The length of the path is A. This is pi r, half of the circumference of the circle. This is B. This is the half of the circumference of this circle. So, A plus pi r plus B plus pi into 4r. So, A value is given 7 meters. B value is here pi r means r value is given 11 by pi. B value is 8 plus pi into 4r, 4 into 11 by pi. If you simplify this one, 7 plus 11 plus 8 plus 44, this 11 pi will cancel. We are getting that is 70 meters. But displacement is considered. This is initial position. This is the final position. You have to go the shortest path. In this shortest path you have to go. That's why this is A, this is 2R, this is B, this is 8R. 4R plus 4R, 8R. Now just I am substituting all these values. A is 7, 2 into R is 11 by pi, B is 8 plus 8 into 11 by pi. I have to substitute all these values. Then we will simplify this one. Then we will get that 7, 8, 15 and 8, 11, 88, 11 by pi. A sub values, if you substitute, you will get the 50 meters is the displacement. So, length of the path if you calculate, you will get the distance. If you shortest distance if you calculate, you will get the displacement. Okay. Now, suppose an aeroplane moves 400 meters. Let us take, this is the map, this is the east, this is the north, this is west, this is south. You have to imagine India map. You can observe that easily. This is the north, this is east, this is west, this is south, this is vertically upward, this is vertically inward. If you go inside, that is inward, that is north. Now, an aeroplane moves 400 meters north. First it is going towards north 400 meters. Towards north, 300 meters towards west, 300 meters towards west. And then 1200 meters vertically upwards. Distance we can easily calculate. 400, just some ordinary sum, 400 meters plus 300 meters plus 1200 meters, distance you will get. But displacement, it is vector addition. You have to take first 400 meters, displacement vector form you take, S bar is 400 J cap. I am taking in this direction, unit vector is J cap. Next, 300 meters west. West means minus I cap, 300 I cap. I am taking vector. Plus, next vertically upward, it is z-axis, vertically upward plus z-axis. So, I am taking that is 1200, z-axis direction, unit vector is k cap, 400 j cap. And now, it is going towards west. So, that is 300 I cap, but west means negative x direction plus vertically upward, 1200 meters vertically upward means this direction. This is z-axis plus z-axis. So, this is 1200 k cap. So, I got that displacement is minus 300 I cap plus 400 j cap plus 1200 k cap. Then displacement magnitude you can find out, that is equal to magnitude of the displacement is, so minus 300 whole square means 300 square, 400 square plus 1200 square. Magnitude we have to find out. Here 100 square is taken as common, 4 square is 16, 3 square is 9, 12 square is 144. Just we are adding all these things, 16 plus 9, 25 plus 144. I am writing that is 169, this is 169, that is 13 square. Now easily we can calculate the square root 100 into 13, that is 1300 meters. This is the displacement. But distance is just ordinary sum because it is a scalar. But displacement is a vector. We have to take the directions also. It is better to take vector form, then easily you can calculate. Now, I am taking that a particle travels from point A to B on a circular path of radius 15 pi centimeters. If the arc length, this is the arc, this is the arc, this arc length AB is 10 centimeters. Find the displacement. This arc length is 10 centimeters. Now, this angle is theta. That theta is arc length by, that theta is arc by radius. Radius is given as 15 by pi centimeters. So, 10 by 15 by pi, that is nothing but 10 pi by 15, that is 2 by 3 pi. 2 by 3 pi is 120 degrees. But I have to find out the displacement. That means actually body is going in this way. This is the path length, that is the distance. But this is the displacement. This displacement, to find out this displacement, you have to know first AC. This angle I got 120 degrees. This angle I got 120 degrees. So that means this is 60 degrees, this is 60 degrees. So, sin 60 is equal to AC by AO. Sin 60 is equal to AC by AO. You know that in trigonometry. So, AC is equal to AO sin 60. So, AO is 15 by pi. This is AO, 15 by pi. Sin 60, you know, root 3 by 2. So, I got that 15 root 3 by 2 pi. So, this is the displacement of the body, but this we got only AC. But you to get the displacement, that displacement is 2 times of this one you have to take. 2 AC we have to take. That's why the displacement is 2 into 15 root 3 by 2 pi I got. So, then 15 root 3 by pi is the displacement we got. Okay? See, we got only AC first. So, displacement means AC plus CB, but both are equal. So, displacement is 2 times of this one, then 2 will cancel, then you will get 15 root 3 by pi. Here we have to remember one point. Distance is always positive. Distance you have to take always positive. Suppose body is moving, whatever be this length, we are considering only length of the path. Length of the path is always positive. Distance is always positive. Displacement may be positive or negative or 0. For example, body started here. It is going in this way. So, displacement is positive. Suppose it is coming in this way. That means this is the displacement. Initially it is at this point, finally it is at this point. This is the displacement. If it is positive, then this displacement is negative. Suppose this body is coming here only and here only, then displacement is 0. Initially it is started here, finally also it comes here, means displacement is 0. But the distance is length of the path, so it is always positive. Distance increases with time if body is in motion. Body is rest, distance will not increase. Body is in motion, distance increases with time. In what direction it is moving? Distance increases. Always increasing function. If it is in motion, if it is rest, it is constant. Distance never decreases with time. Distance never decreases with time when body is in motion. Whatever this one, whatever way it is going, we have to count the length of the path. So, length of the path always increasing when it is in motion. Displacement may increase or decrease with time when body is in motion. Suppose when body is going in this way, displacement increases. Suppose it is coming in this way, then displacement is this one. With time, displacement decreases. When it comes close, displacement decreases. So, displacement may increase or decrease with time when body is in motion. Okay? Next, speed. The time rate of distance travelled by a body is called speed. Units, speed means suppose distance travelled by time. That is the speed. Distance travelled by time. So, suppose from in a particular time, body is moving from this point to this point. This distance by time, that is speed. Speed units are CGS units centimeters per second and SI units meters per second. Speed is a scalar quantity because distance is a scalar. No direction, so speed is a scalar. It cannot be negative because distance never negative. Distance is always positive. So, distance is always positive. The length of the path will increase. Whatever it may be, the length of the path will increase. So, distance is always positive. Distance by time. So, also positive. Speed is always positive. Speed never negative. Uniform speed. Uniform speed means a particle is said to be moving with uniform speed if it covers equal distances in equal intervals of the time. For example, body 2 meters distance in 1 second, next 2 meters distance in 1 second, next 2 meters distance in next second. So, it travels equal distances in equal intervals of the time. Then body is said to be in uniform speed. Okay? So, whatever it may be, whatever be the speed, units are centimeters per second and SI units are meters per second. Non-uniform speed. A particle covers unequal distances in equal intervals of the time. For example, 2 meters in first second. In the next second, it travels 4 meters. In next second, it travels only 1 meter. In next second, it travels 5 meters. That means, in equal interval of the time, it travels unequal distances. Or equal distances in unequal intervals of the time also. equal distances, 2 meters, 2 meters, 2 meters, 2 meters. But this is 1 second, this is 4 seconds, this is 5 seconds, this is 6 seconds. That is also non-uniform speed. So, this is, for example, 2 meters in 1 second, next 4 meters in 1 second. Then it is non-uniform speed because it covers unequal distances in equal intervals of the time. Instantaneous speed. The speed of a body at a particular time is called instantaneous speed. Particular time is not possible. So, we have to allow it to move distance dx in time dt. Small dx in small time dt. This small interval of the time we have to consider. Very small interval of the time. Suppose very small 1 second, 1.000001 second. Body covers dx distance in that time interval dt, then dx by dt is instantaneous. At that time 1 second it covers. Because we can't get at that time in the speed. Because we have to allow some distance to move it for a small interval of the time. If you take that interval very small, then that speed is very close to speed at t equal to this particular 1 second. That is instantaneous speed. Instantaneous speed is dx by dt. We have to do the differentiation of displacement with respect to time, and we have to substitute t equal to that particular second. Then we will get the instantaneous speed. For example, if a particle moving x is equal to t square plus t meters, that means this distance travelled is function of time. Time changes, x also changes. X is distance travelled at time t seconds. Find speed at t equal to 2 seconds. For that t equal to 2 seconds, they are asking, meaning instantaneous speed. Instantaneous speed. For that, we have to do the differentiation of this one, dx by dt. Then you will get 2t, the t square differentiation is 2t, t differentiation is 1. Now, I got v is 2t plus 1 meters per second. Now, at t equal to 2 seconds, so you have to substitute t equal to 2 seconds here, then 2 into 2 plus 1, 5 meters per second. That is, at t equal to 2 seconds, its speed is 5 meters per second, only in that time. Next, average speed. Average speed means the ratio of total distance travelled to total time taken is called average speed. Suppose a body is covering d1 distance in time t1, d2 distance in time t2, d3 distance in time t3. Average speed means d1 plus d2 plus d3. Total distance covered by total time t1 plus t2 plus t3. This is the average speed. This total speed means, average speed means, in this time it travels d1 distance, in this time it travels t2 seconds, in this time t3 seconds travels d3 distance. Average speed means total distance it covered d1 plus d2 plus d3 by t1 plus t2 plus t3. But instead of distances. For example, in time t1, body traveled with speed v1. In time t2, body is moving with speed v2. In time t3, body is moving with speed v3. Then average speed is v1 into t1. A v1 into t1 is d1. v2 into t2 is d2. v3 into t3 is d3 by total time t1 plus t2 plus t3. So, actual formula is average speed is total distance by total time. That is the fixed formula. But distances are not given. Time and speeds are given. Then, what you can write? d1 is v1 t1, d2 is v2 t2, d3 is v3 t3 by t1 plus t2 plus t3. We are calculating distances here. If t1, t2, t3 are all are equal to t, then what you will get that instead of t1 t, we have to write, instead of t2 we have to write t, instead of t3 also we have to write t, by times are t1 is t, t2 is t, t3 is t. Then what you will get now? v1 plus v2 plus v3 into t by 3t. Then t will cancel. So, this is the average speed is v1 plus v2 plus v3 by 3. If time intervals are equal, if time intervals are equal, then average speed is equal to mean of all these speeds. Mean, average, mean of all, mean means sum of the quantities by number of quantities. Mean is sum of the quantities by number of quantities. So, v1 plus v2 plus v3 by number of quantities are 3. So, average speed you will get. Now, actual average speed is, this is the actual formula. Total distance by total time. Suppose, if a body covers distance d1 with speed v1, distance d2 with speed v2, and distance d3 with speed v3, then we have distances, but we have no times. Instead of times, we have speeds, because this is d1. This is actually, we have to get time, but they gave v1, means v1 by d1 by v1 is time t1. Next, d2. t2 is equal to d2 by v2. This time d3. Then t3 is equal to this distance by this v3. Okay. So, average speed is d1 plus d2 plus d3 by instead of time t1, d1 by v1, t2, d2 by v2, d3, t3 is d3 by v3. If d1 is equal to d2 is equal to d3 is equal to d, all are equal, then d1 is d, d2 is d, d3 is d. Then d1 is d by v1, d2 is d by v2, d3 is d by v3. Then this is 3d. By d is taken as common, 1 by v1 plus 1 by v2 plus 1 by v3. Then if you simplify this one, 3, this is d will cancel. So, if you take LCM, v1, v2, v3. So, for this one v2, v3, for this one v1, v3, For this one, V1, V2 by V1, V2, V3, you take this one is upward. So 3V1, V2, V3 by V1, V2 plus V2, V3 plus V1, V3. This is the average speed. We are getting the average speed. So average speed, basic formula is total distance by total time. We have to use that formula only. Based on the situation, we are changing that formula. But d1 plus d2 plus d3 by t1 plus t2 plus t3. d1 is not given, then v1 t1 you have to write. Time is not given, d1 by v1 you have to use. So this is the average speed. So 3v1 v2 v3 by v1 v2 plus v2 v3 plus v1 v3. Velocity. The time rate of displacement. Time rate means displacement by time. The time rate of displacement is velocity. It is a vector. CGS units centimeters per second, SI units meters per second. Same units as speed. But velocity is displacement by time. Displacement by time. Displacement may be positive. Displacement may be negative. Displacement may be 0. Okay. So, velocity may be positive or negative or 0 based on the displacement. This positive, negative, 0 you will get. This is the displacement. Suppose the body is going in this way, but we are not considering that. We are considering this is the displacement by time. Displacement by time. Initial point, final point you have to join this displacement by total time taken is velocity. Velocity has a particular direction. Displacement direction is velocity direction. So, but if you want speed, this path length you have to find out by time. That's why velocity only this length, but speed this length we have to take. So, velocity is less than or equal to speed. Generally, velocity is less than speed, but when velocity and speed are equal, if it travels in a straight line in this way, then displacement is the distance. So, velocity is equal to speed. Now, a ship moves east at 12 kilometers per hour. First, it is going east for 1 hour and then turns exactly towards south. Actually, turns in this way to move for 1 hour at 5 kilometers per hour. Find the average speed and average velocity. Find average speed. First, the ship is moving towards east. 12 kilometers per hour for 1 hour means that the velocity is 12 kilometers per hour into 1 hour. Velocity into time is what? Displacement. So, first we got the displacement in this direction, 12I. Next, it turns towards south. So, how much time? 1 hour, 5 kilometers per hour. So, this displacement is 5 into 1, 5. But this is displacement is along x direction. So, I am taking that is 12I cap. But this is downward direction, means downward means negative y direction. So, minus 5j cap. So, displacement if you want to find out, just you have to find out the magnitude. 12 square plus minus 5 whole square. 144 plus root of 144 plus 25 root of 169. So 13 kilometers displacement. But distance, there is no problem. Simply you can calculate. Distance is just sum 12 plus 5. That is the distance. Directly you will get 12 plus 5. That is the distance. 12 plus 5 means distance by total time. Total distance by total time is average speed. But average velocity is total displacement by total time. Total displacement, how much you got? 13. We have to follow the vectors for displacement. 13 by total time 1 hour plus 1 hour. 13 by 2, 6.5 kilometers per hour. This is average velocity. For average velocity, we have to tell the direction also. So, velocity direction is displacement direction. Velocity direction is displacement direction. So, displacement is what way? 12I. 12I means towards east, next minus 5j. So, some vector is in this way. This is 12, this is 5. This is 12, this is 5. Now, this is theta. This is theta. So, this is theta. Then you can write tan theta is, you know that tan theta is equal to, this is 5, this is also 5. Tan theta is equal to 5 by 12. Tan theta is 5 by 12. Theta is equal to tan inverse 5 by 12. Theta is equal to tan inverse. This one is making, this is theta. This theta is tan inverse 5 by 12. But theta is making east. It is making angle theta, east, after that theta, after that south. East, theta, south. You can write this one as simply tan inverse 5 by 12. You take east this side, south of east. South of east. So, what way we have to decide? You have to tell this direction. This is east, this is south. First, this is theta. East first, next theta, next south. So, east, theta, south. You take east to that side. Tan inverse 5 by 12, south of east. In this way, we can tell the directions. Now, I am discussing one problem. See, figure shows a particle starting from A. Particle starting from A. Now, traveling up to B with speed V. This speed is V. Then up to C with speed 2V, and finally up to A with speed 3V. Find the average speed. Find the average speed. Find the average speed. See, actually, this is AB. This AB, we have to find out this arc length. This is 90 degrees. Theta is 90 degrees, pi by 2. Theta is pi by 2. 120 degrees means theta is 2 pi by 3. 150 degrees means theta is 5 pi by 6. Then this length is, you know that theta angle is equal to arc by radius. So arc length is theta into r, but theta should be radians. Theta should be radians. That's why I am converted into this 90 degrees to pi by 2. Radians, it is in the radians. So this arc length AB is pi r by 2. BC, this angle 2 pi by 3. 2 pi by 3 into r. Angle into radius is arc length. So 2 pi r by 3 is BC. CA, this angle 150 degrees is 5 pi by 6. Pi is 180. 180 by 6 is 30. 30 into 5 is 150 degrees. So that 5 pi by 6 into r is this arc length. Now we got the arc lengths. Pi r by 2, 2 pi r by 3, 5 pi r by 6. This is total distance by total time. To get this time, you know this velocity is v, this time t1 is this arc length pi r by 2 by this velocity. This is first time t1. t2 is this arc length. What is that arc length? 2 pi r by 3 by divided by 2v. Distance by velocity is time. Similarly, that you will get this one. Next time t3 is equal to 5 pi r by 6. This is the distance by this velocity 3v. This is the time. So what I used? Total distance by total time. Then simplification. Here we are taking LCM 6. So 3 to 6 means 3 pi r. 2 into 2, 4 pi r. 6 is 1 into 5 pi r. By here also you are taking LCM 2v, 6v, 18v, LCM is 18v. So we are applying that 9 pi r. Here 3 into 2, 6 pi r plus 18v means 5 pi r by 18v. Then you take 18v by 20 pi r because this value is 12 pi r by 6, 18v by 20 pi r. This is 9v by 5 r. This is equal to 1.8v. Got it? Acceleration. The rate of change in velocity is called acceleration. You know that when you are going in a car, you are increasing the speed or you can decrease the speed. Speed is gradually increasing if your accelerator is on. Suppose if you remove your leg on the accelerator, speed is gradually decreases. So the speed change in the speed, that is change in the velocities, rate of change in the velocity. But we can say that speed and velocity in a particular straight line, if you are going, speed and velocities are equal. Problem nahi hai. So, acceleration means, suppose it is started at this point with speed v1, it ends at this point with speed v2. Suppose it is started with speed v1 and it comes to end with speed v2. In this time is t1 it is started, at this time t1 it is started, at that time t2 it is ended, the motion. Then average acceleration. Average acceleration means v2 bar minus v1 bar by t2 minus t1. T2 minus t1 you have to write. This is the average acceleration. Average acceleration is v2 bar minus v1 bar. T2 minus t1 is time. T2 minus t1 is time. But instantaneous acceleration, at particular instant, at that particular time, if you want the acceleration, that is called instantaneous acceleration. In that instantaneous acceleration, that acceleration is equal to, suppose for this time interval dt, its speed is changing dv, small time interval. Very small time interval dt, its speed changes dv. Then instantaneous acceleration is dv by dt. dv by dt. Average is initial, final, we have to consider. So, final velocity v2 bar, initial velocity v1 bar. So, v2 bar minus v1 bar by t2 minus t1 is average acceleration. t2 minus t1 is this time. But instantaneous acceleration at a particular time, suppose it is started at t equal to 1 second, it is closed the motion at t equal to 10 seconds, but at t equal to 5 seconds, I want the acceleration. But at that time you will not get. It has allowed to move some small interval of the time. That time is dt. Then there is small speed, change in the speed, change in the velocity, dv. Then instantaneous acceleration is a is equal to dv by dt. Acceleration is a vector because this is rate of change in velocity, velocity is a vector. So, acceleration definitely it is a vector. Its direction is in the direction of change in the velocity. Acceleration direction is direction of change in the velocity. v2 bar minus v1 bar direction, if you calculate, that direction is acceleration direction. Units are meter per second square. Why? This velocity meters per second by time seconds, that is equal to meter per second square. That are the units. CGS units centimeters per second square, SI units meter per second square. Suppose for example, the velocity of the body is given by v equal to t square plus t cube meters per second. Find the average acceleration from t equal to 1 second to t equal to 3 seconds. Find the acceleration at t equal to 2 seconds. For this, v1 is time, at this time velocity is 1 square plus 1 cube, 2 meters per second. Velocity at t equal to 3 seconds is 3 square plus 3 cube, that is 9 plus 27, 36 meters per second. Average acceleration is v2 minus, this is v2, this is v1. v2 minus v1 by t2 minus t1, 17 meters per second you are getting. But at t equal to 2 seconds you want. t equal to 2 seconds you want, that is instantaneous acceleration. For that, we have to do the differentiation of velocity. Differentiation of velocity is instantaneous acceleration, that is 2t plus 3t square. 3 into time 2 seconds plus 2 into 2 plus 3 into 2 square, that is 4 plus 12, that is 16 meters per second square. So, at that particular instant t is equal to 2 seconds, 16 meters per second square, you are getting the acceleration. Thank you.